Hello everyone, welcome to Tutor.am, and in this video we're going to be looking at how to calculate basically Boyle's law and the formula, and then we're going to go over a question. So Boyle's law basically has got the formula P1 times V1 is equal to P2 times V2. So this means pressure 1 multiplied by the volume 1 is equivalent to pressure 2 times volume 2. So this is a basic formula that we are going to be using. So now let's try to answer the question given. So the question is saying a gas has a volume of 60 decimeter cubed when it's under pressure of 30 kilopascals. Calculate its pressure changes at 70 kilopascals and at 120 kilopascals. So if we're going to handle this question, first we have to understand what a kilopascal is. So a kilo is basically 100 multiplied by something. So let's first convert this 30 kilopascals, because we can just start by writing off the equation. I think that would be the best way to go about it. Let's write this one first. So the pressure that we are given is 30 kilopascals, and that in just pascals is going to be so we're simply going to multiply 30 by it should be 100 or 1000 to get that in pascals, so that is PA. Let me just write my A. Let me write the generic A, and then this will be multiplied by our volume. So our volume is 60 decimeter cubed, so that is times 60 dm3, and then this should all be equal to what is our pressure 2. So our pressure here given is 70 kilopascals, so we're going to use 70 kilopascals. So 70 kilopascals to pascals, that would be, it's just 3 more zeros at the last, pascal. And then they want us to calculate our volume 2, so this is all being multiplied by volume 2. So if I want to get my volume 2, I can say my V2 is equal to this being multiplied. So we have 30, we have this 30 100,000 being multiplied by 60 decimeter cubed, and then we'll have all this over the 70 or the 7 kilopascals in terms of pascals. So once we do this, we end up finding our volume in decimeter cubed as 25.71 decimeter cubed. So this is a volume at 70 kilopascals. Let's go ahead and try to solve the question, but for the 120, but we will not use kilopascals. Let's just try to use pascals and see what we will obtain. So our second question is asking us to calculate at 120 kilopascals, but let's just try to calculate it at pascals. So if we want to calculate it at 120 pascals, what we are simply going to do is that we are simply going to have the same generic convention. So this statement on top will stay the same because our pressure 1 and our volume 1 are fixed. What is simply going to change is our pressure 2 and volume 2. So our pressure 1 is 30 kilopascals. But here, this is where there is need for conversion. In the first question, we would have just taken it as a 30 exactly, but here we have need to convert the 30 kilopascals into basic pascals. So this will be times our volume is fixed, it's not changing, our volume 1, and then this should be equal to our pressure 2. Let's try to use 120 pascals and not 120 kilopascals, and then this will be times our V2. So once we collect the subject and make V2 the subject of formula, our V2 in terms of solving will be equal to that 30 kilopascals and then one thing that you should notice is that pascals and pascals will have to divide to 1, or as they say in layman's term, they have to cancel. So this 120, remember that it's in pascals, that's why you had to convert, because if that 30 was in kilopascals, we would still remain with a K. So now we have to cancel. So now the pascal and the pascal will go, leaving now the decimeter cubed, which is the unit of volume that we're trying to look for. So then our volume 2 will be basically equal to 15,000 decimeter cubed. And then let's say you didn't convert these to kilopascals, then the final answer that you get, you had to simply divide it. So that is the basics of Boyle's law. If you have liked the video, please subscribe to the channel, and I'll be seeing you guys in the next video. Thank you very much.